Hi everyone. We'll just have a look at the laws of the vibrating strings here. So what I have with me is a nice guitar. So the first law is that the fundamental frequency is inversely proportional to the length of the string, right? So what I'm going to do here with the guitar is that I'm going to pluck one string, right? It's the middle string here, and this is called as the fretboard. So what I'm going to do is wherever I touch the string on the fretboard, right, that the length of the string that gets reduced by that much size. So as I decrease the length, as I'm making the string smaller, the frequency should increase, right? So let's see whether that really happens or not, right? So So as I'm coming down, right, the length of the string is reducing, and you could clearly make out that the frequency is increasing. And the other law is the law of tension. So you see there are these knobs here. By turning these knobs, right, by rotating these knobs, I can control the tension in the string. So uh, let's see whether the frequency is directly proportional to the tension or not. So I'm increasing the tension, and you can see clearly notice that the frequency has increased. So I'll do it again. And now I'll reduce the tension, so you can see that the frequency goes down. So I reduced the tension, the frequency went down, and you can see that the tension, increasing the tension causes a increase in the frequency. Then if you see carefully, there are 6 strings here in the guitar, and this one here, the shiny one, it's quite a high frequency, and this one here is a very thick string, right? And you can clearly make out that the sound of this string here, the first string here from the left, is very low frequency, and this one here, the last one, is very high frequency. So as you can see clearly, this is the thinner one, right? So I can say the mass per unit length of the string, the small m, what we call in the formula, right? The frequency formula is n is equal to 1 by, fundamental frequency is 1 by 2l square root of t by small m, and small m is called as the mass per unit length. So as you can see, this string here has a very small value of small m. Its mass, it's a very thin string, its mass for the given length of the guitar string, right, is very small. So since the denominator is less, the frequency is quite high. Whereas this particular string here, it's a very thick string, right? This first one and the second one, both are quite thick strings, and thicker string means the small m value is higher, and for a higher value of small m, your denominator is more, so the fundamental frequency is less, it's low, and that can be clearly heard here. Okay, so now something about organ pipes. So what I have with me here is a closed pipe. You can see, maybe it's not so clear here, right? This it's a flute, and the pipe is closed at this particular end here, and from here, from this side, right, you can see the light coming through the holes, right? It's an open pipe, and it has these holes on it. So again, my formula for frequency, whether it's a closed pipe or if open pipe, the formula for frequency is that it's inversely proportional to the length of the pipe. So if I allow the air to come out of any particular hole, then I should consider the length of the pipe till that particular hole, right? So as I decrease the length, as I'll open the holes one at a time, right, So as I decrease the length of the pipe, the frequency should go higher, and let's see whether it really happens. Right? So again, that's to verify that for a pipe, right, open or closed pipe, the frequency is inversely proportional to the length. Okay, so that's a harmonium, and we can now see what does it mean by an octave, which in the earlier video we saw is it means double frequency, right? So if I press a key here, so after this key, after this particular key, the eighth key. So if I count this as the first one, so this is the eighth key, and you see they sound very similar. And from here the eighth key again. So that's so these three keys, right? So if I call this frequency as N, then this is 2N, and this one is double of 2N, that's 4N.